Do a recap on the two rules in this chapter. The first one is if you have square root a, b, right, you can actually break it up into square root a times square root b. And if you have a square root a divided by a square root b, right, you can combine them into square root a over b. And in this case here, both a and b are more than 0, right? It makes sense to have both a and b to be more than 0 because square root of a negative number will not give you a real values, and you can't have something to be divided by 0. It's undefined, right? So what we're going to do now is we're going to use these two rules, or rather one of them, to simplify SURDS. Right, let's try to do square root 18 first. Okay, so if you look at what we're going to do now is we're going to list the factors of 18. So we can have 1 times 18 or 2 times 9. You can go on to have 3 times 6, but I think this is not necessary because what we're trying to do here is we're trying to rewrite 18 as multiplications of two numbers. One of them is a perfect square. Why do you want a perfect square? Because square root of a perfect square will give us an integer. For example, square root of 36 will give us 6. Right, 36 is the perfect square. So basically, a perfect square is just the number itself. You multiply, it's the same number and you multiply it twice. So for example, like 2 times 2, that gives you 4, right? So 4 is perfect square. So that when you square root 4, you get 2, right? So like 3 times 3 gives you 9, and 9 is perfect square. Because when you square root 9, you get 3. Right, so we can just rewrite 18 as 2 times 9. So that gives us 2 times 9. And we can apply the first rule here. So that gives us square root 2 times square root 9. And square root 9 is 3. Right, so we can write it as 3 times square root 2. And we can further simplify it as 3 square root 2. So 3 square root 2 means 3 times square root 2. Alright, so let's do another example. Square root 125. Right, so if you look at 125, let's break down the factors. So you can have 1 times 125. You can't have 3. It won't gives you a 125 divided by 125 is not divisible by 3. So we should try 5. 5 times 25. Yeah, 5 times 25 will gives you 125, and 25 is actually a perfect square. So we can rewrite 125 as 5 times 25, and then we can apply rule 1 that gives us square root 5 times square root 25. Square root 25 will give us 5, so that we write it as 5 square root 5. Okay, right, let's do the third example. Alright, so 108, you can have 2 times 54. Right, but both of them are not perfect square. Right, so let's try further. You can have 3 times 3 times 3, 36 times 3. Then 36 is a perfect square. So we can rewrite 108 as 3 times 36. Then 27, we can rewrite it as 3 times 9. Right, so we can apply rule number 1 again. They give us square root 3 times square root 36 minus square root 3 times square root 9. Alright, and square root 36 is 6, so we can write it as 6 square root 3, and square root 9 is 3, so we can write it as 3 square root 3. Alright, and we can factorize square root 3 out because it's common, and then 6 minus 3. So 6 minus 3 is 3, so square root 3 times 3, and we can further write it as 3 square root 3. Right, you may want to try this on your own. The answer you should be getting is 7 square root 2. right? Don't give it up if you don't get the answer. All right, just try a few more times. Make sure that you have applied the rules correctly. If I want to multiply 2 square root 3 minus 5 with square root 3 plus 4, how do I do it? The way to do it is the same as what we have learned earlier on. If you want to multiply bracket a plus y with x plus z, right? Recall that we can use the distributive law. Can take a multiplied with x plus z, positive y multiplied with x plus z, right? And then again use the distributive law to expand each term, right? So the concept that we have used in algebra, you can still use it managing SURDS, right? So the first step is 2 square root 3 multiplied by square root 3 plus 4, then negative 5 multiplied by square root 3 plus 4. Okay, right? So we will have 2 square root 3 means 2 times square root 3, and bracket means times. So what we are having is 2 times square root 3 times another square root 3, right? And then 2 times square root 3 times 4. Okay, and go on to the next one. That will give us 5 times square root 3 and negative 5 times 4. Right, so negative 5 times square root 3. Why negative? Because plus times a negative gives a negative. So negative 5 times 4. Okay, now square root 3 times square root 3. Right, square root 3 times square root 3 is actually square root 3 times 3, which gives you square root 9, and 9 is a perfect square, so square root 9 is 3. Right, so basically if you have square root a times square root a, you will just get a. Right, so we will end up having 2 times 3 plus, so 2 times square root 3 times 4, you can rearrange it to become 2 times 4 times square root 3. And of course 5 times square root 3 is 5 square root 3. 5 times 4 is 20. Right, that's simplified further. 2 times 3 is 6. So this will give us 8. 8 times square root 3, we can write it as 8 square root 3 minus 5 square root 3 minus 20. Let's put all our numbers together. So 6 minus 20. This one here, the common factor is square root 3, so you can factorize it out. Right, so you will have negative 14 plus 8 minus 5 is 3. So that gives you 3 square root 3. So that will be the answer. Alright, what happens if we want to multiply 2 square root 3 plus 4 with 2 square root 3 minus 4? What will I get? Right, so let's link this to the algebraic identity that we've learned earlier on. If you recall, if you have a bracket a plus b times the bracket a minus b, right, recall that we'll get a squared minus b squared. Right, so in this case here, we can let your 2 square root 3 to be a, to be the letter a, 4 to be the letter b. So if you were to apply the algebraic rules, it means we will have bracket 2 square root 3 close bracket to the power 2, then minus b, which is 4, so bracket 4 squared. Right. So what does this mean here? What does 2 square root 3 to the power of 2 means? It means it's 2 square root 3 times another 2 square root 3. So let's put the numbers together, then put the SURDS together. So 2 times 2 will give you 4. Square root 3 times square root 3 will give you 3. So that gives us 12. Okay, or you can easily use a calculator to help you get the answer. So, but when you use a calculator, you have to ensure that put a bracket first, followed by 2 times square root 3, close the bracket, and then power 2. Right, so that gives us 12, and 4 squared is 16, so 12 minus 16 gives you negative. So this is what you do when you need to multiply surds in that sense. With all the knowledge that we have learned, let's try to solve these questions. So you are asked to find the unknowns A and B that satisfy the equations given. So how do we go about doing it? If you look at the left hand side, obviously we will have to expand it. So to expand it, we will use the distributive law. So that will give us A bracket 10 minus B square root 27 plus square root 3 bracket 10 minus B square root 27 equals to 28 plus 16 square root 3. Right, so that gives us A times 10 is the same as 10A, and A times B times square root 27, that gives us AB square root 27. Square root 3 times 10 is the same as 10 square root 3, and then we have B. Alright, so recall that square root A times square root B, we combine them to get square root AB, right? So that will give us square root 3 times 27. Right, so let's continue further. 10A minus AB. Right, so square root 27, we learned earlier on how to simplify it. We can write it as 9 times 3. Why do you want to use 9 times 3? Yes, because 9 is a perfect square, and square root of a perfect square will gives you an integer. That's the reason we break it up into 9 times 3. Right, and 3 times 27 is 81. Alright, so let's continue further. So I would have 10A minus AB times square root 9 times square root 3. Right, I'm showing you every step, right? So square root 81 is 9, so that gives me 9B. Right, let's continue. And A minus square root 9 is 3, so they give us 3AB square root 3 plus, okay, this is like pretty long, but do not give up, okay? You need to have a lot of patience if you want to see if you want to reach the destination. Okay, remember what we're saying, math is actually a journey, right? So you have to be patient. So what we're going to do now is, if you look at the left hand side, right, we're going to group the constants together and then the surds together. So what are the constants we're talking about? So things like 10A, negative 9B, they're constants. Right, so we're going to put them together as one group. And then, of course, negative 3AB square root 3. Can you see there's a square root 3 there? That's a surd. And then the 10 square root 3, there's also a surd. So we're going to put them together. So I would write 10 square root 3 positive first, and then followed by negative 3AB square root 3. Okay, so what I'm going to do next is that I'm just going to do a comparison. Whatever that is on the left, I'm going to compare with whatever is on the right. So I'm going to compare constants on the left with the constant on the right. So the constant on the left is 10A minus 9B. So that will be compared with 28. Alright, and then I'm going to compare this 10 square root 3 minus 3AB square root 3, compare it with 16 square root 3. Alright, so what I'm going to do here, I'm going to divide by square root 3 throughout. Right, divide by square root 3, divide by square root 3, divide by square root 3. So what do you get? You will have 10 minus 3AB equals to 16. Okay, and I'm going to call this equation 2. And I'm going to go back to my 10A minus 9B equals to 28. I'm going to call the equation 1. So you would realize that we have two equations with two unknowns, so we have to solve them simultaneously. Alright, this is what I'm going to do. I'm going to work from equation 1. So from 1, I'm going to make A the subject. I'm going to call this 3. I'm going to substitute 3 into 2. So I would have 10 minus 3, 28 plus 9b over 10 multiplied with the b. Okay, this is what I'm going to do because 28 plus 9b over 10 is a fraction. So I'm going to write 3 as 3 over 1. And I'm going to write b as b over 1. Right, because 3 divided by 1 gives you 3. And b divided by 1 gives you b. Alright, so the next step is I'm going to multiply the numerator. And also multiply the denominator. Okay, here it's a bit tricky. Right, so I'm going to make everything instead of fractions, I'm going to just make it a non-fractions. So what I'm going to do is, you see this is the denominator is 10, so I'm just going to multiply every term with 10. Okay, this is a very neat trick to make fractions to become a non-fractions. So 10 times 10 give me 100. So of course this is our purpose. What we want is to make it a non-fraction, so you end up getting 3 bracket 28 plus 9b with the b behind. 16 times 10 is 160. Simplify further. So 28 times 3 will give us 84. 9 times 3 is 27b. Alright, we're going to expand further. That will give us 84b. Now be careful, plus come negative gives me a negative, so that gives us negative 27b squared. Right, so you see that we end up getting a quadratic equation. Right, I'm going to make it a positive coefficients of b squared, so I'm going to multiply by negative throughout. So you will get 27b squared plus 84b plus 60 equals to 0. And this you can use a calculator to help you get the answer. Right, so b can be negative 10 over 9, or b can be negative 2. Right. So the story does not end here because you still have to find the values of a. So when b, so how do I find the values of a? I have to use equation 3. Okay, I have to use equation 3 here. So I'm going to sub b equals to negative 2 into equation 3. So when b is equals to negative 2, a will be 28 plus 9 bracket negative 2 divided by 10, and that gives us 28 plus 9 bracket negative 2 divided by 10, and that gives us 1. Alright. So the first set of answer will be b equals to negative 2. Therefore b, so the first set of the answer will be a equals to 1, b equals to negative 2. So the second set of answer is when your b is equals to negative 10 over 9. So you sub into equation 3 again. You get 9 over 5. Right, so the second set of answer will be a equals to 9 over 5. b equals to negative 10 over 9.